Hi, and we're back. We're going to check out number 7 which is a problem similar to number 7 from the exponential function test from April 2019. This could be useful for you if you're doing a do-over or if you are preparing for a future test that I might offer you. So here's the situation. Instead of polio, we're going to deal with swine flu. Swine flu, an H1N1 type of flu virus, there are different categories, is a type of flu that sometimes spreads during flu season. It has a moderate infection rate. One can expect that 1.4 to 1.6 people will be infected by a single person over a 3-week period. If 25 people were initially infected with swine flu and the surrounding population hasn't been vaccinated, how many weeks will it be before this number, this number, and this number of people are infected? Give high and low numbers because there's a low and high infection rate. You might be wondering how we're going to have a fraction of a person. These are statistical numbers that are used for large numbers of people. So that's how you end up with fractions of a person. There are no chainsaws involved to get 4/10 or 6/10 of a person here. So the first thing we got to do is come up with our basic equations. There's going to be 2 equations because we have 2 infection rates. We're going to start off with an initial value that we've been given, 25 people. So y equals 25. And then we need to create a base. Our base is either going to be our low rate, because for each one of those 25 people, each round, they're going to infect this many or this many. So we'll have 25 times 1.4 raised to the x, and we're going to make it x over 3 because x is going to be weeks here. So 3 weeks would be 1 round. So 3 over 3. 3 weeks would be 3 over 3 for our x one. We have a different equation for the 1.6 infection rate. So y equals 25 times 1.6 raised to the x over 3 power again. And for each one of these, we're going to have a y equals 220. Y equals 450, and we're going to be seeing where each of these functions intersect, what time, what x value or number of weeks each one of these intersects with y equals 220, y equals 450, and y equals 2000. So let's go over to Desmos and let's set this up. So I'm going to do both equations. So y equals our initial number of people of 25 times 1.4 raised to the x weeks over 3 weeks power, and y equals 25 times 1.6, not 1/6, 1.6 raised to the x weeks over 3 weeks per infection rate. Problem you might notice very quickly, they have a big divergence once we get out to a certain number of weeks. So now let's set up our different levels. We had y equals 220 people, y equals 450 people, and y equals 2,000 people. Okay, so let's check out the low one for the faster rate. This is the 1.61. We're going to take 13.9 weeks. We'll round that to the nearest tenth. For the slower one, we'll take 19.4 weeks. We'll round that again. So 13.9 and 19.4. So for this one, it's going to be 13.9 and 14 or 19.4. So 13.9 weeks and 19.4 weeks to get to 220. 19.4 weeks. So somewhere in that range, that's a quicker or longer time for that to happen. Let's check out 450 people. Okay, so I'm going to make those disappear so they're not in our way. And let's see if I can make make them disappear. What I'll do is I'll make this disappear. Okay, so now we're looking at y equals 450. So for our faster one at 1.6, it'll take 18.4 weeks or 25.8 weeks for the slower rate. So 18.4 or 25.8, between 18.4 and 25.8 weeks. I'm going to go back up here and write in weeks so you don't think I'm talking about badgers. Units do matter. Okay, for 2000, I'm going to make the 450 horizontal line go away, and we'll just focus on the y equals 2000. So the faster disease spread will reach 2,000 people in 28.0 weeks. If I round that to the nearest tenth, I get 28.0. Round this, so this one is 39.1. The slower will take 39.1 weeks. So here we go, 28.0 to 39.1. 28.0 and 39.1 weeks. Okay, so that's the range of possibilities for each one of these. And that's all you got to do with this one. You got to come up with a basic function. A lot of people overthought it. They didn't see that this rate was actually the growth factor for the disease. It is the rate. It is our exponential rate of 1.4 or 1.6. We need to set up our exponent as x over 3 because if x is weeks, we're going to say that. If you wanted to do it in days, you could certainly do that, and then it would be 20. Then it would be x over 21, and then we'd be concerned with how many days we're talking about, and we could do that. But I asked about weeks, I believe, so stick with that. I hope this has been useful. I'll make some more videos in the next couple of days to help you further with this stuff. Thank you very much.